Hi everyone! Today, we're diving into an interesting topic that's crucial for understanding modern software performance, the difference between green threads and virtual threads. These concepts help us write programs that can do many things at once, making our applications faster and more responsive. Let's break down what each one means and how they compare. First, let's talk about green threads. Imagine your program needs to do several small tasks. Green threads are like tiny tasks managed entirely by your program itself, not by the operating system. Think of it like a single chef, your program, trying to juggle multiple cooking tasks, green threads, all by themselves in one kitchen. The operating system, or OS, only sees one big chef working. This means green threads are very lightweight. Creating and switching between them is super fast because the OS isn't involved. However, there's a big catch. If one of these green threads needs to wait for something, like data from the internet, the entire program might stop and wait, because the OS only sees that single chef. Also, because the OS doesn't know about them individually, green threads cannot truly use multiple CPU cores at the same time to speed things up. They are always running on just one OS process. Early versions of Java used green threads, and languages like Erlang also employ a similar concept for their processes. Now, let's move on to virtual threads. These are a more modern and powerful evolution, often seen with Java's project Loom. Virtual threads are also very lightweight and managed by the program's runtime, similar to green threads. However, there's a key difference in how they interact with the operating system. Instead of the OS only seeing one big chef, virtual threads use a few carrier threads, which are managed by the OS. Think of it as having a few highly efficient sous chefs, OS carrier threads, in your kitchen. When a virtual thread needs to do some work, it gets assigned to one of these sous chefs. If that virtual thread then needs to wait for something, like network data, it doesn't block the sous chef. Instead, the virtual thread unmounts itself, and the sous chef becomes free to pick up another waiting virtual thread. This is a game changer. It means that when one virtual thread blocks, only that specific virtual thread stops, and the underlying OS carrier thread can immediately start working on another virtual thread. This allows your program to scale to millions of concurrent tasks very efficiently. Unlike traditional green threads, virtual threads can also truly utilize multiple CPU cores because they can map to multiple OS carrier threads, enabling real parallelism. So, the main differences boil down to this. Green threads are entirely user-managed and largely invisible to the OS, leading to performance limitations like blocking the entire process and an inability to use multiple CPU cores effectively. Virtual threads are also user-managed and lightweight, but they intelligently map onto a smaller number of OS-managed carrier threads. This smart mapping allows them to achieve massive concurrency, prevent blocking of the entire process, and fully utilize multiple CPU cores for true parallelism. They offer the best of both worlds, the lightness of user-level threads with the power and efficiency of OS-level concurrency. Thanks for watching. If you found this explanation helpful, please give this video a thumbs up, subscribe to the channel for more tech insights, and let us know in the comments what other topics you'd like us to cover.